Acid, base and salt. This chapter explains the nature, properties and reaction of acid, base and salt. It also introduced the pH scale, which help in measuring the strength of acid and bases. Acid definition, properties and reactions. Definition of acids. Acids are sour in taste. Acid turn blue litmus into red. Acid conduct electricity in solution. Acids are corrosive in nature. Strong acid can burn the skin. Chemical properties of acids. Reaction with metals. Acid plus metal produce salt plus hydrogen gas. 2HCl plus Zn produce ZnCl2 plus H2. Reaction with metal carbonate and bicarbonate. Acid plus metal carbonate bicarbonate produce salt plus CO2 plus water. CaCO3 plus 2HCl produce CaCl2 plus CO2 plus H2O. Pass CO2 gas through lime water CaOH2. It turns milky due to the formation of calcium carbonate CaCO3. Reaction with bases. Neutralization reaction. Acid plus base produce salt plus water. HCl plus NaOH produce NaCl plus H2O. This reaction is called neutralization, which helps in treating acidity in the stomach. Reaction with metal oxides. Acid plus metal oxide produce salt plus water. 2HCl plus CuO produce CuCl2 plus H2O. Metal oxides are basic in nature, so they react with acid to form salt and water. Base definition, properties and reactions. Definition of bases. Bases are substances that release OH negative hydroxide ions when dissolved in water. For example, NaOH, KOH, CaOH2, NH4OH. Physical properties of bases. Bases are bitter in taste. Bases turn red litmus into blue. Bases are slippery or soppy to touch. Bases conduct electricity in solution. Chemical properties of bases. Reaction with acids. Neutralization reaction. Base plus acid produce salt plus water. NaOH plus HCl produce NaCl plus H2O. Reaction with metals. Base plus metal produce salt plus hydrogen gas. 2NaOH plus Zn produce Na2ZnO2 plus H2. A pop sound is heard when a burning matchstick is brought near. Reaction with non-metal oxide. Base plus non-metal oxide produced salt plus water. CaOH2 plus CO2 produce CaCO3 plus H2O. Non-metal oxides are acidic, so they react with bases to form salt and water. Indicators and their uses. Indicators are substances that change color in the presence of acid or bases. Indicator: litmus paper, red in acid, blue in base. Phenolphthalein is colorless in acid, pink in base. Methyl orange, red in acid, yellow in base. Natural indicators are turmeric, cyanurose, litmus, etc. Synthetic indicators are phenolphthalein, methyl orange. pH scale, strength of acid and bases. Definition of pH scale. The pH scale measures the concentration of hydrogen positive ions in a solution. It ranges from 0 to 14. Acidic solution pH less than 7. Neutral solution pH equal to 7. Basic solution pH greater than 7. pH value of some common substances. Hydrogen chloride acid HCl pH 1, lemon juice pH 2, vinegar pH 3, milk pH 6.5, water pH 7, blood pH 7.4, baking soda pH 9, ammonium solution pH 11, sodium hydroxide NaOH pH 14. Importance of pH in everyday life. pH in digestion. The stomach produces HCl pH equivalent to 2 for digestion. Excess acid causes acidity, treated using antacids like baking soda. pH and tooth decay. When pH is in the mouth drops below 5.5, tooth enamels start dissolving. Brushing teeth neutralizes acid and prevents cavities. pH of soil and plant growth. Plant grow best in soil with a suitable pH range 6 to 7.5. Farmers use lime CaO to reduce acidity and gypsum to reduce basicity. Salt and their uses. Definition of salt. Salts are formed when an acid reacts with a base. For example, HCl plus NaOH produce NaCl plus H2O. Common salt and their uses. Common salt NaCl used in food making chlorine gases. Baking soda NaHCO3 used in cooking antacids. Washing soda Na2CO3 used in detergent. Bleaching powder CaOCl2 used in detergent. Some important questions and answer about acid, base and salts. First question, why is hydrochloric acid used in digestion? HCl helps break down food by creating an acidic environment in the stomach. Why does soap feel slippery? Answer, soap contains bases like NaOH or KOH, which are slippery in nature. What happens when an acid is mixed with water? Answer, acid release H positive ions when dissolved in water. The solution becomes less concentrated. Why do farmers add lime to the soil? Answer, lime CaO neutralizes excess acidity in soil, making it suitable for crops. Why does a strong acid have a low pH? Answer, a strong acid releases more hydrogen ions, making the solution highly acidic, pH less than 3. Conclusions. Acid release hydrogen ion and bases release OH negative ions. Neutralization forms salt and water. The pH scale helps determine whether a substance is acidic, neutral, or basic. Salt have various applications in daily life. This chapter provides a strong foundation for understanding the chemical behavior of acid, base, and salt, along with their importance in real life. Thanks for watching.